Today we are going to revise the double integral. Okay. Before we start revising double integral, we have to go through the technique of double integral. Before this one, we have to distinguish between double integral in a Cartesian coordinates. Okay. Cartesian coordinates and polar coordinates. Okay. Before you do anything, you have to think about it. Are you going to integrate with respect to x and y, or you have a function of x and y, and all the time they write it here dA, right? But in the other side, you have a double integral, a function of r and theta, also dA. What is dA? dA is the area element, right, over this region. Okay. So yes, dA, the area element, could be dx, dy, and could be dy, dx. This is the area element. The area element. Okay. But what about the area element in the polar coordinates? The area element in the polar coordinate here is r dr d theta. Okay. So it is very important to distinguish between the area elements in the Cartesian, could be dx dy, or could be dy dx. But in the polar coordinates, dx dy or dy dx corresponding to r dr d theta. Okay. Let's go for the Cartesian first. The Cartesian coordinates. In the Cartesian coordinate, we also have to distinguish between two integration over rectangular area, rectangular area, and non-rectangular area. And non-rectangular area. Non-rectangular area. Okay. Okay, so what does it mean, a rectangular area? Rectangular coming from rectangle. So when you have a rectangle, you have the width and the length starting from A to B, right? Okay, you go from A to B. And also, if you take a part of this one, so your Y starts, say, from C to D. So this is a rectangular area, right? It is exactly like a rectangle, right? Okay, so your double integral will be whatever your function is, and dx dy, and x from A to B, and y from C to D. If you have this case, you are lucky, because you can swap between x and y, so this will be exactly the same as from C to D, from A to B, you still have your function as it is, and you can swap dy dx. Not only this, it is also, if you have your function f of x, f. Your function f of x and y is exactly two functions, one of x and the other one of y. So this one will be the integral of g of x dx from a to b, a multiplication of the integration of the other function of y and integrating with respect to y from c to d. All of us knows we cannot distribute the integration over the multiplication, but only f and only f, right? Your function can split into two functions, one function of x, g of x, and the other function is h of y. So you can split the double integral into two one variable function integrals, right? But in general, you cannot distribute the integration over the multiplication or over the division. All of us know that from the integration of one variable function. Now, we finish the lovely case, which has no problem at all and makes everything easy. Let's go in the next step to non-rectangular area. Okay. Double integral over non-rectangular area. By the way, before I start here, non-rectangular area doesn't mean curvature only. It means if you have a triangle, this is non-rectangular area, right? If you have a piece of circle, it is non-rectangular area, right? If you have a piece like this one, it is non-rectangular area, right? So all of these ones are non-rectangular area. Okay, so we can start for integrating our function. Maybe we start integrating first with respect to x and then with respect to y. Okay? And x here, if it is non-rectangular area, you may have x as a function of y here, right? So I call it x1. And I may have x2 here also as a function of y. But outside integration will be always, or most of cases, as a constant, right? So I call it as I used to have for y from c to d, right? Okay. If you can integrate with respect to x first, you have no problem. Go ahead. Okay. What about if not? Yes, if not, swap dx dy into dy dx, right? If you swap dx with dy, is it just swap it and full stop? No, of course. Be careful. With the integration limits, okay? Or with the boundary of the integration, with the boundary, the lower bound and upper. Okay, if I swap and I start with x first and I would like to have dy first, So I have to specify dy first. How to find dy, the boundary of dy? I coming from down to up, right? And I see what I hit first and what I hit last. And this is my boundary of y. If I have this one, also I coming from down to up to have y1 and to get y2, okay? Also here, I'm coming from up, down to up to have, this is y1 and the last one will be y2. This is how to find the limit of y when you swap y with x, depends on your region of the integration, okay? Now, we will go for the polar coordinates. Before I go to the polar coordinates, if I have dy by dx, okay? Okay, so this is up to the region. Before I go, if I have dy by dx and I couldn't integrate with respect to y first, what I have to do? Yes, to find the values of y, you coming from down to up. To have the value of x, you coming from the left to the right. So this will be x1, this will be x2. Also here, you're coming from left to right, coming from the left to right to have the value of x. Is it clear? Now I can start with double integral over polar coordinates. Okay. Are you voluntarily go for polar coordinates? Of course not. Okay. If it is compulsory, yes. If it is optional, why I'm going for polar coordinates? It is easy for me to deal with the Cartesian coordinates, but sometimes you have to go to the polar coordinates. How it comes? Yes. When I'm asking you to have the double integral of e to the x squared plus y squared dx dy over any region. I don't care about the region now. I'm caring about why I'm using polar coordinates. In this case, I cannot integrate with respect to x. So I know here, I said, if not, you can swap dx by dy. Okay, so I thought about reverse the order or swap dx dy into dy dx. What do you have now? You have the same problem, right? But I have the same problem. What is the problem? I cannot integrate with respect to y also. So I have the same problem with y. With integrating with respect to y. Okay? So what you are going to do now? It is compulsory to go to the polar coordinates, which make tempting for you. You know what is the relation between the polar coordinate and the Cartesian coordinate. I know x squared plus y squared will equal to the radius r squared, right? And I know dx dy equal to r dr d theta. So yes, up to your region, you will find the r and the theta, and your integration will be very easy because this one will be changed into what? Into e to the r square, sorry, r dr d theta. This is very easy integration by substitution, right? You take r square, whatever it is, x, u, v, and this is very simple one, right? And you know the radius starts from 0 or from any value to the other value, so it will be constant. Okay, yes, I'm lucky. So this one, most of time, will be changed into rectangular area, but in the polar coordinates. So it will be easy integration, this one. Okay? Now, I finish revising the technique of the double integral. Let's go for some example for this one. Okay, I will try to solve for Abdullah. I'm going to solve this question. Okay, I'm just going to write it down. Okay, the integration from 0 to 1, the integration from 3y to 3 and e x squared dx dy. Thank you very much, Abdullah. I'll start to solve it. Can you tell me, can we integrate straightforward with respect to x? Any one of you? So I ask myself before I start, and I integrate with respect to x, because x is first, right? Okay, I will think. Can we know the integration of e to the x squared dx? Can you do it by substitution? No. Can you do it by integration by parts? No. Okay. So yes, I have to do something different. So I can start with y if I have a problem with x. Okay. So this one cannot be integrated cannot be evaluated by using any integration technique, right? Any integration method. Okay. Substitution. By parts. Partial fraction. All of these one we have it in. Okay. So yes, because we cannot. We have to think about what? Yes, reversing the order. Now I have to think about reverse the order. What does it mean, reverse the order? It means, and just instead of dx dy, I have dy dx. But I cannot reverse the order without thinking about the boundary of the integration. So I start with the boundary of y and the boundary of x. Okay, what is my region? My region, x between 3y to 3, right? X between 3y to 3. Why I'm writing 3y, the smaller one? Because it is down here, right? Because this is the smaller value, this is a bigger value, right? And x from 0 to 1, y from 0 to 1, okay? Can any one of you graph this one and share it with me, please?
دكتور الاريا اللي هي between الاكس والواي.
Yes, between this one. Yeah, this bold one, right? Yeah. Okay. So this is your area, okay? Keep it. Okay? Keep it. Now, what we can find for reversing dx dy instead of dy by dx, I would like to have the y value first, right? So I go from down to up, right? So when you come from down, you hit the x-axis, right? So in the x-axis, all of y's are 0, right?
Yes.
Okay. So y start from 0 and end up with this line. What is the equation of this line, Abdullah? X equal to 3y, right? X equal to 3y.
Yes.
Yes, here it is. X equal to 3y. So what is y here? Y will be what? X over 3, right? Okay?
Yes.
So,
Yes.
okay. So now we know how to get the boundary of y when you're reversing. We start from y first, so I go from down to up. When I hit first the x-axis, or in my region. In the x-axis, y is 0, and then I will hit this line. I know this line is x equal to 3y, right? So y will equal to x over 3. So just a minute, I will just graph it from you, Abdullah. X equal to 3y, and you have y from 0 to 1. Okay. So, okay, thank you very much, Abdullah. I will back to my solution. Okay, so this is my region. Now, instead of having this one, I write it again. Zero to 1. I'm going to reverse. So this one will be changed into double integral e to the x squared, and instead of dx, I will start with dy and then dx. Now I have to find the boundary of y first, right? So what is the boundary of y? How you get it? I will get from down to up, right? As I said again, you hit first this one. This is the x-axis. So at x-axis, y equal to what? 0. And then you hit this line. This line is x equal to 3y. But I'm looking for y. So y equal to what? X over 3, right? So x over 3. Okay. What about the boundary of x? I know this is the lower value and this is the upper value, right? So the lower value of x is 0. The maximum value of x is what? What's x here? I know y, x is the maximum value of x is 3. So this is a 3. So I can write here 3. Now I have no problem with this one because this one I can take it behind this one because I'm integrating with respect to y. So integrating from 0 to 3, and I get this e to the x squared here, and back to my integration from 0 to x over 3 for only dy, right? For only dy. After I finish this one, I will back to integrate with respect to x. What is the integration of dy? Is y, right? So we have from 0 to 3 dx squared from the beginning, and you integrate dy from 0 to x over 3, and when you finish, you integrate with respect to x. Now this is what? This is the integration from 0 to 3 e to the x squared and you have x over 3 minus the lower bound, so it's minus 0 dx. This is very easy integration by substitution. Even you can do it by the calculator. Can you do it by the calculator, please, and give it to me? Okay, so this is by the calculator. It gives you 1,350.3. Okay, we finish this integration, and we know why we swap and why we reverse the order of the integration, and we have how we can get the boundary when we reverse. Okay, if we would like to start for y instead of x, we have to go from down to up. Okay. Also, we have another example here. Okay. Can we integrate with respect to y first? This is my first question. No, of course, because I cannot integrate sine y squared. Okay. But I can integrate sine y all of it square, sorry. Okay. But I cannot integrate. So this is, I have to write here because I cannot integrate with respect to y. So I have to reverse, right? So I have to reverse, okay, the order, the integration order. Okay, so I know now I have to swap this one, dx dy. Before I swap, I have to graph the region first, right? The region of the double integral. Okay, so how we can graph this one? Okay, this is the margin, and I'm thinking in the margin, right? So I know this is y, right? So y bigger than x because x is the lower bound, and less than 1, and x between 0 and 1, right? So if I would like to sketch this one, x and y, right? And I know y equal to x in this one, right? This is the line, y equal to x. So y start from this line and end up with 1. So I start from this one to this one, right? And x from 0 to 1. So remember, I start with y, lower value of y is x. So I start from this line because when I'm coming from out down to up, I start with this one. So I have to get this one, and then I end up with this one. So my area will be exactly this one, not the lower bound, lower rectangle. Okay. Why? Because y greater than x. So I have to hit the lower bound first. So I will hit the line first, right? And then end up with the horizontal line y equal to 1. Okay. So this is my region. This is my area. Now I know how I can swap and change the order of the integration. Okay. Now this one will equal to the double integral for sine y squared. Instead of dx as dy, I start with dx first and then dy. Okay. What is the value of x? How to find the value of x from this U region? You go from the left to the right. When you come from the left, you hit the y-axis first. In the y-axis, x equal to 0, right? So x equal to 0. and then you end up with this line. You are lucky because y equal to x. So if it's y equal to x equal to 1. Now, what is the lower bound of y? The lower bound of y is the minimum value of y, which is 0, and the maximum value of y is 1. So I have from 0 to 1. You don't have the problem because this one, you can take it here, okay? Because you are going to integrate with respect to x. So you have no problem with this one. So this one will be exactly from 0 to 1, and I get this sine y square, okay? And then I'm integrating from 0 to y only for the x. After I finish this one, I back to integrate with respect to u. Okay? What is the integration of dx? It is x from 0 to y, right?
Yes.
When you finish, you can do this one by your calculator, okay? From 0 to 1 sine y squared, and when you substitute, you have y minus the lower substitution, 0 and dy. So you can integrate this one from 0 to 1 sine y squared and y dy. Again, by substitution, you can let u equal to y squared. So du will equal to 2y dy, okay? And you will have the integration equal to integrating from 0 to 1. Instead of this one, you have sine u, okay? And instead of y dy, you have du over 2. Now, remember, this is the value of x. This is not the value of u, right? Once you finish, get back to this. You have half outside. What is the integration of sine? It is minus cosine. And instead of u, you have y squared. So this is not x, y squared, right? And okay, and you have to put the bound y from 0 to 1. Okay. Now, what is the value substitute by 1 and 0? You will get the value of the integration. Okay. Is it clear? Okay, let's go for this example. Again, I should have a margin here, and I think in my margin, just not to have a mess in my solution. Okay. So as I said, can you integrate as it is given to you? So you start with y. No, because I have a problem with cosine y squared, right? Cosine y squared dy. I cannot integrate this one, right? I cannot integrate this one. Okay. So next, if I avoid this one, I have no problem. So avoiding integrating with respect to y first. May I solve the problem? Let's reverse the order, right? So let us reverse the integration order. Yes, to reverse the integration order, you have to do what? Sketch the integration region, right? Sketch the region of the double integral. This is very important before you start doing anything over here, right? Okay. So let's sketch this one. How I can sketch this one? As I told you, y start first. Y equal to x squared. Y equal to x squared. This is what you are going to hit first from down, right? So this is what? This is parabola, right? This parabola is a vertical or horizontal one? Is a vertical one, right? And its head, okay, is 0 and 0. Okay, so yes, I know it is parabola and its head is 0 and 0. Going concave up or concave down? Concave up because it is positive here. This is here, you have a positive, right? So if it is positive, so it will be here. Okay. So this is a parabola. And then y equal, start from this one to a, right? What about x? X from 0 to 3, right? So where is my region? As I said, when I come in from down to up, I hit what? I hit the parabola first, right? Okay. And then I hit y equal to a. Y equal to a is a horizontal line, right? So yes, I know this is my region here. Then this is my region, right? This is how to know where is your region. Okay. Now I would like to swap. Yes, go and do it. Integration for x cosine y squared, and instead of I have dx and then I have dy. Now I change from y to x. So what is the lower bound of x? To have the lower bound of x in the region, to find the values of x are coming from the left to the right. When you go from the left to the right, you hit what first? You hit the parabola or you hit the y-axis? You hit the y-axis, right? When you hit the y-axis, what does it mean? At y-axis, x is 0. Okay, so I have 0. And then I hit the parabola. But the parabola y equal to x squared. But I'm looking only for x. If y equal to x squared, so x will be positive or negative root square x. Which one I should take? The positive or negative? I'm going to vote the positive because, sorry, I missed. This is y, not x. Because my region is above x-axis, okay? And also, my x is positive. So I have to only take x positive root square. But if my area in the left side of x-axis, okay, I will go for a negative one, right? Now I know this is a positive y squared. And what about the y? To find the y, I have to go from down to 1. I know I will hit the parabola first, but now I have to get a constant. What is the minimum value of y? 0. What about the maximum value of y? Is a. Yes, when I'm reversing, I have no problem with the cosine y squared because no need for it. I'm going to integrate with respect to x. So this one will be integrating from 0 to a, and I will take sorry. Now I have no problem, as I said, with the cosine y squared because I will take it outside here. Okay. And then I will integrate from 0 to root square y, only x, dx. And when I finish this one, I'll back to integrate with respect to 1. The integration of x dx is what? Is x squared over 2, and you have to substitute by the upper bound first, and then with the lower bound. Okay, now 0 to a cosine y squared. When you substitute by x equal to root square y, so x squared will be only y, right? So you have y over 2. When you substitute by 0, you have 0. Again, using a substitution, you can do this one, right? So integration by substitution. Let u equal to y squared. So again, du will equal to 2y dy, right? So y dy will equal to du over 2, okay? So I will have the integration from 0 to a for cosine u, okay, du over 2, right? And of course, I have 2 down here, right? So I substitute by y dy, but I still have u 2 here, okay? So this is the 2, right? So I will have 1 over 4 integration from 0 to a cosine u du. What is the integration of cosine? It is
Sine.
sine u, thank you,
Welcome.
from 0 to a. But remember, 0 and a, it is not the value of u, it is a value of y, right? So remember to write here and to remind yourself, this is not the values of your variable here, u, but this is for y. When you finish, get back to your original variable. So this one sine y squared, and from 0 to a, no need to write y because this is, now it is 1 over 4 sine y squared, sorry, I substitute by y equal to a squared minus the substitution of sine 0. So this is, I know sine 0 is 0, so I end up with sine a squared 1 over 4 sine a squared. Full stop. Thank you very much. Yes, you cannot use the calculator here because you have the normal calculator, of course, not the programmed one, because you have a constant here, symbol here, right? So this is why I have done it by substitution to the nth, right? But when you have a number, yes, you can use your normal calculator.